This time we'll be looking at the magnetic force on a current carrying wire. We know what is a conductor. Conductor has electrons, so many charges moving in it. Assuming this is a conductor, this conductor has a length L. I have charges moving. And if this conductor is placed in an external magnetic field, we're interested in knowing the force that is involved. And at this point, we said that F is equal to B IL sine theta, where B is the magnetic flux or magnetic field strength. It means the same thing. B is the magnetic flux in Tesla. T, I is a current in ampere, and L is the length of the wire or the conductor in meters, and theta is in degrees. So if you're asked to calculate the magnetic force on the current carrying conductor or wire, this is the formula we use. F is equal to BIL sine theta, where all the parameters have their usual meaning. So we have an example here. A wire of length 0.3 meters carries a current of 4 ampere or 4.0 ampere. It is placed in a uniform magnetic field of 0.20 Tesla at right angles to the field. Find the force on the wire. So as usual, we appeal to the formula. The length is 0.3 meters. Always check if the units given are in SI unit. Sometimes this will be given in cm or millimeters. You need to change the SI unit. The I is given as 4 ampere. The magnetic field strength or flux is given as 0.2 Tesla. Find the force. Of course, it is placed in a uniform magnetic field of 0.20 Tesla at right angles. If this is the field lines, and the conductor is placed at right angle. So what happened? We have maximum force. But if it is placed parallel to the field, the force becomes 0. But at that point, no angle is involved, and theta will be equal to 0. And from this formula, F is equal to BIL sine theta. If theta is 0, the whole of this becomes 0. But in this case, we know that theta is equal to 90 degrees because it is at right angle to the field. So in this case, we now appeal that F is equal to 0.2 times, remember this is the formula we are using, BIL sine theta. So B is 0.2 times I is 4 times L is 0.3 sine 90 degrees, which you can write as 0.2 times 4 times 0.3 times 1, because sine 90 is 1. So by the time you play around with this, if you calculate this, if you multiply this, you will have 0.8 times 0.3. And if you work out that, we'll have 0.24. We have 0.24 Newton. As simple as this. So if you have any question or difficulty in understanding a particular concept here, you put it in the comment section.